Welcome to Algebra 1, Semester 2, Unit 8B, Section 9.4. This is the first section of this unit. It's a fairly short unit. The last part of this unit, Unit 8A, you learned how to multiply polynomials, classify and show their degrees, add and subtract them. Now this unit, you will be doing something slightly different. You'll begin factoring. Basically, factoring is the reverse of multiplying. So here's what you do in factoring. You ask yourself, what could go into each of these terms? The number that can divide into each of those terms would be a 2, so we pull it out to the front. 2 times what would be 4m? That would be 2m. 2 times what would be negative 2? That would be negative 1. So now what you did in the last unit was you took this and you multiplied it to give me that. You would take 2 times 2m, give me 4m, 2 times negative 1 and give me negative 2. So this time you're doing the reverse of distributing. Okay, next one. What goes into both negative 5 and negative 10? That would be a negative 5. And then you take the variable and you take the smallest exponent. There's a 2 here and a 1 there, so take the 1. Negative 5x times what gives me negative 5x squared? That would be an x. Negative 5x times what gives me a negative 10x? That would be plus 2. What goes into both 6 and 15? That would be 3. So we have 2y plus 5. Over here, there is no number that I can think of that would go into negative 2, positive 1, and negative 9. So all that I can do is pull out the variable with the smallest exponent, so it's m to the first. I don't have to write a 1 there. M represents m to the first. So it would be negative 9 m squared plus m minus 2. So basically we just took 1 off of each of their exponents. So now, in this next part, we're going to factor 4 factors. And this is just like what you've done with 2 factors. I call it a 2 by 2 instead of a 4. I take the first 2 and I factor out of those. That's an x and an x squared. So x can come out. X times x will give me x squared. X times 1 will give me positive x. Now I take this factor and I write it again right here. With that binomial written twice, now what I do is I ask myself, what do I need to multiply this one by to get this binomial? So what times x will give me 3x? That would be a positive 3. Then I check and make sure the second number works as well. 3 times 1 is 3. Now I look at what I have here, and I can see that I've got a binomial here and a binomial here that are exactly the same and can be factored out. So I factor out that x plus 1 and write what's left in another binomial. Now if I were to FOIL this, I would actually come up with this answer here. Next problem. Again, underline the first 2. There's no numbers that come out of 1 and negative 5, but I can write the variable. The smallest exponent would be to the second. X squared times x equals x to the third. X squared times negative 5 gives me negative 5x squared. Now I take this binomial, I write it again, and I ask myself, what do I need to multiply this binomial by to get this binomial? And that would be a positive 2. 2 times x is 2x, 2 times negative 5 is negative 10. Now from this step, I factor out that x minus 5 because it's the same in each side of the expression. Now what's left is x squared plus 2. Next problem. I have x cubed minus 4x squared minus 6x plus 24. I underline the first two. The reason I did read that was to make sure that it was in standard form, descending order on the exponents. That's always best to do when you're factoring. So what will go into 1 and 4? There is no number, but I do see that they have like variables. Now they are not completely like terms because they have different exponents. So I go with the smaller of the exponents. X squared times x to the first would give me x to the third. X squared times negative 4 will give me negative 4x squared. Now I repeat this binomial and ask what would I multiply this by to get this. It is negative 6. Now I factor out the x minus 4 and I bring down in another binomial what was left in that expression. Last one in this set. Go ahead and turn off the video. See if you get the same answer that I do. See me in class if you don't. Or talk to another student and see if they got it. Okay, now can we solve equations by factoring? Well, let's see. If we have 4x squared plus 24x equals 0, we could factor out a 4x from those two terms. That would leave us with x plus 6 equals 0. Now, we've got a property that says, it's zero product property that says if you have two items sitting here, and you're going to multiply them together, and you end up with 0, then one of these two items has to be 0. This times this equals 0. So either this is equal to 0, or this is equal to 0. In fact, there are two answers to this equation that will make it true. The first answer is 0. So if I plug 0 back in there, it would make it true, because 0 squared is 0 times 4 is 0, plus 24 times 0 is 0. Add 0 and 0 together, we get 0. Next answer, subtract 6 from each side, we get x equals negative 6. So if we plug negative 6 in there, negative 6 times negative 6 is a positive 36. I better do this one down here just so I don't lose you. Negative 6 times 6 is 36. And 24 times negative 6 is negative 144. 4 times 36 is positive 144. Positive 144 minus 144 equals 0. Okay, this one, they set the 0 on the other side, thought that they'd be confusing. They weren't. Just move it back over here if that makes you more comfortable. Underline the first two. X times x plus 6. X plus 6. That would be a plus 2. Now do just like you did up above. Factor out the x plus 6. And put in the other factor what was left. And now we can solve for 0. Either this one or this one equals 0. So x plus 6 equals 0, or x plus 2 equals 0. Subtract 6 from each side, we get x equals -6, or we get x equals -2. On your own, plug those back in, make sure that they work. Next problem, we can factor out a -8p, and that leaves p plus 3 equals 0. So when we solve that, -8p equals 0, divide by -8, and we get p equals 0. P plus 3 also equals 0. Subtract 3 from each side, p is a -3. That's the end of page 3. And that's the end of that section of these notes. Thank you very much.